The Wind Farm Whisperer, A New Era of Maintenance, written by Neil deGrasse Tyson. Imagine a world powered by the wind. Giant turbines gracefully spin, converting nature's breath into clean energy. These majestic giants, however, are not without their vulnerabilities. Maintaining wind farms is a complex and costly endeavor. Traditional methods rely on scheduled inspections and reactive repairs, often leading to downtime and lost energy production. But what if we could predict and prevent these issues before they even arise? Currently, technicians climb these towering structures, meticulously examining gears, blades, and sensors. This manual process is time-consuming, expensive, and sometimes dangerous. The future of wind energy demands a smarter solution. Enter the world of artificial intelligence, where algorithms are being trained to listen to the whispers of wind turbines, detecting subtle signs of trouble long before they become catastrophic failures. This is the dawn of a new era in wind farm maintenance, one driven by the power of data and the ingenuity of AI. Deep learning dilemmas. The struggle is real. Deep learning models have shown promise in anomaly detection. However, they face challenges when dealing with the complexities of time series data, like that generated by wind turbines. These models often struggle to capture long-range dependencies and subtle patterns within the data. Traditional deep learning approaches sometimes fall short in this domain. They might miss subtle anomalies or raise false alarms, leading to unnecessary maintenance and wasted resources. Imagine trying to find a single misspelled word in a vast library. That's the challenge these models face when sifting through the constant stream of data from a wind farm. The sheer volume and complexity of the information can overwhelm traditional deep learning algorithms. They might mistake normal fluctuations for anomalies or miss crucial warning signs hidden within the data. This is where a new breed of AI comes in, one that can not only handle the complexity but also understand the language of wind turbines. MIT's AI breakthrough, SigLLM, takes the stage. Researchers at MIT have harnessed the power of large language models, or LLMs, to revolutionize wind turbine maintenance. LLMs, known for their ability to understand and generate human-like text, might seem like an unlikely candidate for this task. However, their ability to process sequential data and identify patterns makes them surprisingly adept at analyzing the time series data generated by wind turbines. MIT's innovation lies in a novel framework called SigLLM, which stands for Signature-Based Large Language Model. SigLLM transforms raw sensor data into a symbolic representation, akin to a language that the LLM can understand. Imagine translating the complex symphony of vibrations, temperatures, and pressures into a language that the AI can comprehend. This symbolic representation captures the essential patterns and anomalies within the data, allowing the LLM to identify potential issues with remarkable accuracy. This breakthrough has the potential to transform wind farm maintenance, making it more efficient, cost-effective, and ultimately, more sustainable. Decoding the wind. How LLMs predict the unpredictable. LLMs, trained on vast datasets of normal and abnormal turbine behavior, learn to distinguish between the two. They can detect subtle deviations in performance, signaling potential issues like blade damage, gearbox wear, or generator malfunctions. This early detection allows for proactive maintenance, preventing costly downtime and maximizing energy production. Furthermore, LLMs can forecast future performance based on historical data and current operating conditions. Imagine having a crystal ball that can predict when a turbine might experience a problem. LLMs can provide this foresight by analyzing historical data, weather patterns, and current operating conditions. This allows wind farm operators to optimize maintenance schedules, allocate resources efficiently, and ensure the turbines are always operating at peak performance. The ability to predict and prevent issues before they arise is a game changer for the wind energy industry. LLMs versus the world, a battle of anomaly detection. MIT's research shows that SigLLM outperforms state-of-the-art anomaly detection models in wind turbine data analysis. In a head-to-head comparison, SigLLM demonstrated higher accuracy in identifying anomalies, reducing false positives, and providing more reliable predictions. This superior performance translates into tangible benefits for wind farm operators, including reduced maintenance costs, increased energy production, and improved overall efficiency. The results speak for themselves. SigLLM consistently outperforms traditional methods, proving that LLMs are not just for processing language but also for understanding the complex language of machines. This breakthrough has the potential to revolutionize not just wind energy, but any industry that relies on complex machinery and generates massive amounts of data. The future of anomaly detection is here, and it's powered by LLMs. The future is bright LLMs poised for innovation. The potential of LLMs in anomaly detection extends far beyond wind farms. Researchers are exploring their application in various fields, including aviation, manufacturing, and healthcare. Imagine LLMs monitoring aircraft engines for signs of wear and tear, predicting equipment failures in factories, or even detecting anomalies in medical images. The possibilities are as vast as the data itself. As LLM technology continues to advance, we can expect even more innovative applications in anomaly detection. Imagine LLMs that can not only identify anomalies but also suggest solutions, optimize system performance, and even design more resilient infrastructure. The future holds a world where machines can understand their own health and communicate their needs thanks to the power of LLMs. A sustainable symphony. LLMs orchestrating a greener future. The development of SigLLM and the application of LLMs in anomaly detection represent a significant step towards a more sustainable future. By optimizing wind farm operations, we can accelerate the transition to clean energy sources and combat climate change. LLMs are not just analyzing data, they are orchestrating a symphony of sustainability, ensuring that the wind continues to power our world for generations to come. The wind is a powerful force for change, and with the help of LLMs, we can harness its full potential. By listening to the whispers of wind turbines, we can create a cleaner, more sustainable future for all. This is the promise of AI, and it's a promise worth keeping.